All right, so today's lab is a correlation of Bedrock lab. Looks like that. All right, so first off, this right here is what's called a stratigraphic section. And what that is, basically it's a model to represent the bedrock of an area. Now to make one of those, there's different ways you can go about doing it. So let's say, for example, these were the rocks of a certain area and they wanted to make a stratigraphic section to represent these rocks. All right, one way of doing it is I could drill down and do a core sample from the top all the way down to the bottom. And this is an example of a core sample here. So you could drill it down here and then you could pull these pieces out, identify the rocks and like how thick the layers are and stuff like that. So that's one way you can, then you could take that data and make it into one of these guys, right? That's one way of doing it, but it's a pretty expensive way of doing it because it costs a lot of money to drill those core samples. Another way you could do it is you could send a man out into the field and he could go to a spot where the rock layers are exposed like this, and he could make measurement. He could take rock samples, identify it, and then make a measurement to the thickness of the layers. So he might go out there. Now this part's straight up and down. He could use like a meter stick or something, or tape measure and measure how thick that one is. That's pretty easy. Now this one, being in an incline, would be a little bit more difficult. So how they go about doing that is like you might use like a meter stick and a level, and then he'd look through the level and make a point right there. Then he'd know the distance from there to there would be like 1 meter, and then do the same thing over here, use a level. Then he'd know from there to there is 1 meter and so forth. So that's how you can measure the thicknesses of something that's on an incline. So you can take samples of that. Now for real tall cliffs, what you can do is you don't necessarily have to climb the cliff to get the thickness of that layer. What you can do is you do some mathematics. If I know the distance from the cliff and I look up to the rock layer that I'm trying to measure, if I know this distance and I can measure this angle from the distance and the angle, I could calculate how thick that layer is. So most of these things are done by people out in the field making measurements, right? Taking samples and making measurements. Now, on my example here, there are 2 different layers of shale. Right? Now, when they're describing the rocks of an area, they have to distinguish between this layer of shale and this layer of shale. So each one of these separate layers is called a formation, and they give each formation a name. So this might be like the Smith Shale, and this might be like the Jones Shale. A lot of times they're named after a spot where the rock layer is exposed, so it's named after a geographic location. But so they might say like the Smith Shale has a lot of trilobites in it and is dark gray in color, while the Jones Shale is a light gray in color and has lots of brachiopod fossils or something like that. So they're both shale, but they might have distinctions between them. But anyways, so let's say like either you took core samples like this, or you had someone in the field measuring it, you make a stratigraphic section. All right? Now, one stratigraphic section only tells me what's going on for a small section of Earth's history. All right? We know about Earth's history by looking at the rock layers, oldest layers on the bottom, youngest layers on top. But the Earth has been around for a really, really long time. So in any one section, it's just one small glimpse of Earth's history. If we want to look at a bigger chunk of Earth's history, what we have to do is we have to correlate rocks from around a bunch of different areas. So like this guy right here, if I could correlate him with other rock sections, then I'll have like a bigger portion of Earth's history. So let's say with like these guys right here, right? This represents one area, this represents another area, this represents another area. So this represents this much Earth's history, that much Earth's history, that much Earth's history. But what if I take them and I match up their rock layers, like these two match up, like that. And over here, like this one matches up to that one matches up to that one. If I correlate them, what I have now is, instead of just one small piece of Earth's history, I now know what happened from here all the way up. All right, so that's how we know what things were like at the oldest times of Earth's history. Is if you take rocks from around the world and you end up correlating them like this, you end up getting a history of what happened in the early parts of the Earth to up until today. All right. So that's what we're going to be doing today. Is the lab is dealing with correlation of rocks. All right. So what you have to do is, all right, so for the lab here, here's like an intro. And what the rocks that we're looking at are the rocks that you find around Cayuga Lake. Now, this person who made this lab obviously doesn't live in the area, because no one in the area calls it Lake Cayuga. People who live in the Finger Lakes call it Cayuga Lake. But anywho, so these are the various rock formations that you can expect to find in the area. All right, so it tells you Sherburne Shale, shale with increasing sand towards top, Ludlowville shale about 25 meters thick. So it has the rock formation, it tells you some other information about it. All right, so what you have to do is, first off, on this page here, you have a bunch of different stratigraphic sections. So each one of these is the rock layers in a certain area. So what you want to do is, you're going to take some colored pencils here and make a key, right, with your colored pencils. Then you're going to color in the various rock layers according to the key over here on the right. Right. So I'm going to do some speed coloring. Ready? All right, so I'm done with my coloring, and now I have something that looks like this. All right. Now, what I'm going to do with this is, now I'm going to take a pair of scissors, and I'm going to cut these pieces out. All right, cut these pieces out, including the key. All right, so the key, you can just cut the whole thing out. I'm going to cut all these pieces out. All right. So here we go. We're going to do some speed cutting. And now, I'm done with my speed cutting. So here are all my pieces like this. All right, all nice and colored and so forth. All right. All right, so what I want to do is I'm going to start correlating them. All right, so you're going to look at rock layers that match up. All right, so for me, I look and I see a blue with for the limestone with a real narrow green sandstone layer. So that matches up quite nicely with that right there. So those two correlate like that. All right. Now here's another one that has a nice little green limestone layer with the blue. It's got the red to match it right there. So that's going to go like that. All right. And now, if you notice, some of these have the letter T, or they all have the letter T at the top of them. That means that that's the top side. So you know if you have your rocks right side up or upside down. So the T stands for the top. All right. So you're going to keep on doing that. You're going to keep on doing that. It's like that. It'll go right there, and so forth. So you're going to keep on doing that, correlating and matching all your pieces together. All right. Once you have the whole thing done, all right, you want to take a picture of your completed thing. And
good morning, Midlands. In a few moments, we will be conducting a planned fire drill. When the alarm sounds, please evacuate the building in an orderly manner. Everyone must remain 6 feet apart and wear masks throughout the entirety of the drill. Once outside, we must be at least 300 feet from the building and socially distant. Teachers, please remember to supervise students as you exit the building. Please make sure that no exterior doors are propped open when you exit the building. Students, you are directed to remain with your teacher throughout the evacuation. Again, in just a moment, we will be conducting a planned fire drill.
all right, so hopefully we get this done before the fire. All right, so what you're gonna do is these guys here, once you have it all correlated, if you're physically handing in the paper, you want to glue the pieces to the paper right here. If you're submitting it digitally, you can just take a picture of your final thing. All right. So once you're done with that, then there's questions that go along with the lab. All right. So that is the correlation of Bedrock lab, and I got to get out of here before I burn to death. So, adios.